asked David Webb about why he started teaching with more open-ended problems in his courses. And here's what he had to say.
My name is David Webb, and one of my research interests is teachers' classroom assessment practices. So I found that when I had experiences as a learner where I saw instructors bringing in a range of ideas from students and then using those ideas to adapt instruction, I found my own learning to be more engaging, more interesting. I found that mathematical ideas that I thought I knew quite well, I found I didn't understand them until I heard other perspectives on those. So my firsthand experiences as a learner, when I saw some of those approaches to instruction being modeled, it was easy for me to be convinced that this is the way I should really teach.
So this is a really big deal. We often aren't able to realize some of the places that we can grow and improve without seeing others' approaches. And so bringing open-ended problems into our courses can really help students in this way. So next we're going to delve into a case study that involves taking a pretty traditional lecture course and making just one kind of smallish change along these lines. And this approach involves adding one open-ended rich problem to the weekly homework, and then training students in giving one another peer feedback on these problems for a few minutes during class once a week. And so one of my colleagues, Dan Reinholtz, he's a math researcher and educator, developed an intervention as part of his PhD work. And he was really frustrated by the high failure rates in college calculus and wanted to do something about it. And so this intervention was aimed at supporting college calculus students.
So hi, I'm Daniel Reinholtz, and I'm a postdoctoral researcher who focuses on how to design learning environments in math and science. So the intervention was called Peer-Assisted Reflection, or PAR for short. And the idea is that as students analyze the work of their peers, that could actually teach them reflection skills. Because often it's much easier for us to look at and be objective about somebody else's work rather than trying to look at our own work, which is sometimes too close to us to really see the flaws in it. So the PAR cycle is an activity that has mainly 4 parts to the structure. And the way that it works is it's incorporated into students' weekly homework assignments. And so students might sort of have all their regular problems, and then they'll have one special problem that's called the PAR problem. And the PAR problem is a little bit different from traditional problems. They're generally difficult and very conceptually rich, so there's lots of places for students to really dig in and kind of experience and work with the mathematics. So those are kind of the tasks you want to choose to do this. So students will, as part of their weekly homework, they'll work on one of these problems, and after they finish it, there's another page that helps them self-reflect on their work. And the self-reflection is just really quick, a couple of check boxes for different things they can look at in their solutions, like did I explain my work, or did I use proper units, or those types of things. And so it kind of helps students remember to think about these things when they're doing later problems. Then after students go through that reflection, they come into class and they work with a random partner, so they get a diversity of opinions, and those 2 people will trade their work with one another, spend about 5 to 7 minutes just silently reading the work and giving written feedback, and then they trade back and they actually have about 5 to 7 more minutes to talk with one another, discussing their feedback. They could discuss the problem more generally, anything they struggled with or found interesting. And so after students do that, they have all this information that they can take to improve their work, and so they have the option to revise their assignments before they turn them in. And so that's sort of the last step, is they actually get feedback that they get to use rather than just getting feedback that they take and move on. Over 98% of the students actually revise their work.
So I asked Dan if he could tell me a little about his learning goals for this intervention. And here's what he had to say.
So PAR is really a holistic intervention with a lot of different learning goals. I mean, at the most basic level, the hope is that students understand the concepts in calculus at a deeper level. And that could be evidenced by them learning how to explain or communicate their ideas better, which is a major focus. And also for them to reflect and analyze on their own work and how they're understanding their own understanding. And I think the final piece is just dispositions. Because this is a collaborative activity, it teaches students how to interact with one another. And because it's an iterative activity, students work on a problem, reflect, get feedback, and revise. So they actually learn how to be more persistent over time because they see initially they fail, and if they stick with it, they can actually get it over time.
One thing that I think is really cool about this intervention is that it closes the feedback cycle loop. So if you recall our diagram from earlier, in a lot of traditional courses, it might be possible to get feedback on homework, but the rest of the cycle, formulating a plan and revising, aren't usually built into homework. So this is a problem a lot of my colleagues have noticed and created interventions around. So for instance, Kathy Perkins also saw this as a problem in physics courses.
So one challenge we saw in our class was that students would complete the weekly homework, but they really didn't have any incentive to go back and revisit that homework and see where they were successful and where they still needed to work and learn more. So in the homework correction problem, what we had students do was review their homework submission compared to the posted solution, and then really examine the reasoning they had used in their answer to the reasoning in the posted solution, and identify where their reasoning had gone astray, what reasoning they needed to modify and advance in order to have a full understanding of the problem.
So in the PAR problem intervention, the structure naturally builds this in. And I also wondered how Dan supported students to communicate their feedback to one another, as this is a hard skill to develop, and these students didn't have a lot of experience doing so going into the course.
So I think there's sort of two key components to the training. The first was just upfront in the class, taking time with students to let them know this is something different from what you've normally done. It's going to take some time to learn how to do this, and sort of talking about the key features of things that you would do when looking at somebody's work, or what does it take to have a productive conversation with one of your peers, because you're criticizing one another, but not as a way to insult one another, but to improve and learn. And so sort of starting out to establish those norms is really important in the beginning of the semester. And the other thing that I think really matters is giving students sort of regular training and opportunities to practice this, because giving feedback is hard. It's not something that they've really been taught to do traditionally. One of the things I would notice is a lot of students would just say, oh, it looked good. And they didn't really know sort of the places where they could give feedback. And so I found the self-reflection was really helpful, because it pointed out specific things that students could look for, be it using explanations or how pronouns were used or other things like that. And so students actually started to take the things they saw in their self-assessments and apply those in their peer feedback. So kind of giving the right scaffolding seems really crucial.
Lastly, I asked Dan to tell us about some of the research he's done on using this intervention.
So I developed the PAR intervention in introductory college calculus, and the studies took place over 2 semesters. Each semester there was one teacher who was teaching with PAR, and then the other sections were used as control groups to look at student learning. And so with those controls, comparing during the first semester, experimental who got PAR and those who didn't, the PAR students actually had a 13% higher passage rate. And during the second semester, there were improvements to the intervention itself based on things that I learned. And so then during second semester, students actually improved their success by 23%.